Yes. So all of you look at the first question. The question 1 is given as that generator matrix is this. So what is the length of the code and all, right? So I will, there are 11 students, 10 students are there. I will go one after the another. Okay. Sonal, can you tell me what is the length of the code? Siddhi? Okay. I'm coming from back. Shruti?
So the length of the code is 7.
7. So how do you know that it is 7?
So I looked at the code function.
Okay.
It's from F24 to F27.
Very good.
So
That also you came to know by the size of the matrix. Right?
yes.
By looking size of the matrix, it is 4 cross 7. So 7 is gives the length of the code. So dimension of the code is
4.
4. So this is actually k cross. So n is equal to 7. Now you answered. So k is equal to 4. You can mute. Yeah. So now Pratiksha, what is the size of the code? So cardinality of C. Hello, Pratiksha. Yeah, Pranita.
Sir, since it's binary, it's 2 to the power 4.
2 to the power 4. Very good. 2 power k. Yeah, very good. So again, for you only, it is because it is very simple. What is the rate of the code?
Sir, it's 4 by 7.
4 by 7. Good. Okay. What about the distance of the code? It is little tougher. Aditi, what is the distance of the code?
3.
Yeah, it is 3. So, but we need proof. Okay, all of you think about. Yes, correct. Distance of the code is 3. Okay. So answer is correct, but how it is, so you come up. Okay. So weight distribution of the code. What are the weights? What are the possible weights? So total there are how many? Cardinality of C is equal to 2 power 4. इसका मतलब क्या है? There are total 16 code words are there, right? So now any code word you take, weight is at most at least 3 now. Distance of the code is 3 means there is a code word of weight 3, right? And remaining, so are at least 4, 5, 6, 7 like that, right? What is the maximum weight? It is 7, right? So now weight distribution of the code. What are the possible weights we'll get? So can you tell me the numbers? At least 0 is there. Yeah, so I'll ask one of you now, right? Yeah, Nikita, can you tell me if 0 is there here? Okay, that means that you are telling that there is a code word with weight 0. What is that code word?
Sorry, sir, what did you say?
Is there a code word with weight 0? Weight 0. In this code, in this set of code words, is there any code word whose weight 0? Okay, okay. I do not know why. What is the problem? Yeah, Pragati, yeah, go ahead.
So the 0 code word.
0 code word, weight is 0. Okay. Tell me how many code words are there with weight 1?
Sir, no code words.
Okay. Why you are saying that there are no code words of weight 1?
Because distance is 3
Yeah,
at least.
okay. So that means that there are no code words of weight 1. Weight 2 also no, right?
Yes, sir.
So weight 3. Okay. So is there any at least one code word is there of weight 3?
Yes, sir.
Can you tell me, give me one? I am asking you, at least give me one code word of weight 3. Hello, Pragati. All of you to Pragati.
Yes, sir.
Sir, it's the first
No,
row.
wait, Shruti. Yeah. Pragati. So she already, Shruti ma'am gave. So the first row, why you are not telling Pragati? First row weight is 3. You are thinking I am asking everyone. No, I am asking you only. Again, weight of second word also 3. Weight of third word is also 3. So we have code word of code. So we have weight 0 code words are there. Weight 1 are not there. Weight 2 are not there. Weight 3 they are available. So weight 4 are available.
Yes, sir.
Yeah. How do you know?
Sir, the fourth row.
Okay. What about weight 5? So now question to all of you. Are there any code words of weight 6 and weight 7? Weight 5 and 6 and 7. Yeah. So do
No,
not answer about the 7 part at the think about, but 5 and 6. So Shruti, you have a complete answer for all 5, 6, 7.
yes, sir.
Okay, then wait actually. Let them give time. So this is one of the important thing. That's why. So I will ask one by one again. So Pranita, do you tell me that are there any code words of length 7?
No, sir. I don't think there is
Okay.
code word
Pragati?
of answer.
Pragati?
So length 7 is not there.
Not there. So can you add all the rows? Is it a code word? If you
Yes,
add
sir.
all the rows, is it a code word? First question, Pragati.
Yes, sir. It is a
So
code
add
word.
them. So add them, all of them here.
111
1, 1, 1, 1, 1.
111.
So what is the
Yes,
weight of the code?
7.
Then what happened? So there is a code word of weight 7 also, right?
Yes, sir.
Yeah. Okay. So I'm just asking that what are the possible weights? Okay, I'm writing as a set here. Weight distribution, but I need how many also later. So 3 is there, 4 is there, so 7 is there. So 5 की 6 के बारे में अभी पता नहीं, right? So Aditi, can you say something about 5? You are facing little difficulty. Okay, good, no problem. That is good. Actually, this is not a easy question. Yeah, Shruti, now go to.
Because I was not able to properly think about 5 and 6, I
Okay. Yeah. Okay, that's okay. That's okay. Yeah.
find number of code words of each weight, but yeah.
Okay, you know that. Okay, so let us come to.
No, sir. Just a moment. I will need.
Okay, no problem. Yeah. So Shruti, go ahead.
Sir, I think R1 plus R4 gives you 5. Weight
Okay.
5.
See. So see, try to understand now. All of you, I given some clue. Shruti also not able to figure out. So now I am giving some clue to all of you. So my code C contains 16 words, right? That is first thing. And second thing is that it contains all ones vector that you understand. 1, 2, 3, 4, 5, 6, 7. Yeah, it is there. And you know one thing, right? So these are the some of the hints I am giving to you. Every code word actually comes from these rows only. First row, second row, third row, fourth row, adding 3, adding 2, adding all of them like that. If I add all of them, I got 1, 1, 1, right? So by adding these only, I'll get. And also, if I take two code words, their sum is also should be there. So now this 1, 1 is 1, 1, 1 is there. It will tell you something. So it will tell you something. Suppose there is a code word of length 5, then what happens? Yeah, now do not tell me answer. Just keep quiet.
Sir, I
Please,
got
please,
it.
please, yeah, I understand. Please keep quiet for some time. Suppose there is a code word of length 5, which is available here. Okay, then what happens? So the beauty of this is that it has 1, 1, 1, 1, 1, 1, all of them 1 or 1 or them. Okay. So suppose Manlo there is a code word of length 5. Yeah, now over to Pragati now again. Is it can have? Just say yes or no. Pragati. Can it have a code word of length 5? Hello, Pragati, are you there?
Yes, sir.
So can it have a code word of length 5? Don't worry. So still you are not clear about. Okay, Pranita.
Yes, sir. It don't have a code word of length 5.
Oh, how do you know?
So the distance is 3, and if we add any of these three, any of the rows, any two of the rows, we will be getting four places where they are non-zero. So we
No,
will
no.
not be having. Okay.
That's okay, but you are going to more complicated approach. So this you are not utilizing 1, 1, 1, 1, 1 wala.
Yes, so that means there are no 5 zeros
Mm,
in
uh,
one code word.
uh,
That
yeah,
means
yeah.
like
So you
distance.
okay? Yeah, you understand actually, but you are
Yeah.
not specifying properly. You are very much clear. I understand that. Okay, good. Aditi.
Uh, so yeah, there won't be any. I was able to find out all the numbers.
Okay. So not that
But
way.
sir, by so if we add all four, then we get 1, 1, 1, 1.
Okay. Okay. No. So see. So again, try to think about. Suppose you have a code word of. So there is a code word of weight 5. Weight 5. Weight 5 means what?
It has 1 at 5 places.
Once at 5 places. Yeah. Now you have this code word all ones. And C is a linear space, subspace. That is the hint. Yeah, somebody want to say.
Sir, I can see.
Okay. Yeah,
Sir,
please.
if we just add them, you will get ones at two places,
Hmm.
which will tell you that the weight is 2, but there is no code of weight 2 because the distance is 3.
Very good. That is the thing.
So you will not have weight 6 also.
Weight 6 also. Very good. Right? If there is a code word of weight 5, that means there are 5 ones are there. If there are 5 ones are there, already all ones are there. So I'll add them. Then so is it not telling a beautiful part that once I know the distance something and this vector is there, I can rule out many code words. Is it not beautiful?
Yes, sir. I didn't think like that.
No, that's okay. That's okay. No.
But once you gave the hint, it became.
Okay. No, that is okay. मेरा मतलब है कि see coding theory beautiful subject है. See actually it is actually human lot of things. You start solving problems, you will enjoy like anything. And it is not very complicated subject also. It is not demanding that you need to know a lot of mathematics, only addition and these aspects. So that's what I'm telling you, that you start allocate time that you will enjoy a lot. Okay, so fine. So that is the things that so now weight distribution weight. So later you see that I asked that weight enumerator polynomial. Weight enumerator polynomial means that now, so first of all, it is W0 plus, so no, there is no W1, right? That is 0. W2 is also 0. So next I will get a W3. W3 z power 3 plus W4 z power 4 plus directly now W7 z power 7. बीच वाला सारी की सारी 0 है. So now I already know W0 is value is, yes, Pragati?
Sir, 0.
W0 is 0. W0 is the number of code words
Sir,
of
1.
1. Okay. So it is a weight enumerator polynomial. So it is 1 plus. So last wala also you know. Z cube coefficient is how much? How many words of length 3 are there?
7.
So 7. Okay, good. Thanks. How many code words of? Then automatically this one also 7.
Yes.
Right. Very good. So and this one is 1. Right. So this is the weight enumerator polynomial. Right. So I hope I can give question of this type. Right. So I'm training you that what are the things you need to do for the exam preparation. Is it a perfect code? Okay, so before going further, so parity check matrix is somebody computed? Any one of you?
Sir.
You computed? Okay, Aditi can tell.
0, 1, 1.
So can you tell me first what is the size of the matrix?
3, comma
3 by?
3.
3,7.
3, comma 7.
7. Because see, generator matrix code is k comma 7. Then a parity check matrix size is n minus k comma 7. Right? Okay. Now, so forget about G and all now. Once it is 3 comma 7, so each row contains what? I'm not computing. See, you can compute by using, already it is in this G in the standard form, IK and A. So I can easily compute this, but I'm not computing that way. I'm thinking, okay, what to do without actually doing. So how many, this each column is a vector of length, how much?
3.
3, very good. So how many 3 vectors are there here like that with length 3, length 3?
7.
7 are there. Good. So there 7 are there. So is there any chance that it contains a 0 column?
No.
Oh, why it cannot contain 0 column? If it contains 0 column, then the distance of the code is less than or equal to 1.
Yeah.
Right? So remember that if they are k linearly dependent columns, then the distance of the code is less than or equal to k. But if I have k linearly independent columns in a parity check matrix, then distance is greater than k. So this is you need to know. By by law of trichotomy, you cannot have one side you have less than or equal to k, the other side you have greater than k. Okay. If we have k linearly independent vectors in the parity check matrix, then the distance of the code is greater than k. If they are linearly dependent, then less than or equal to k. Right? So we should not forget this. This is a mantra, very beautiful thing. So I am telling in each and every lecture. Proof also you need to understand that. Okay. So it does not contain 0 vector first. But now total how many vectors will be there with the length 3?
8.
8. But no 0 vector is not there. What is happening then? Can 2 vectors can be repeated?
No.
That's the question. If they are repeated, what happens? If 2 vectors are
Linearly
repeated,
dependent.
linearly dependent. If they are linearly dependent, what do you know about the distance of linearly dependent? Yes, correct. If 2 rows are same, मान लो, so 7 rows है. Zero row is not there. That we came from the distance of the code by computing. So some people will compute this, then compute the distance of the code. Anything is okay. So even there is a method to compute distance of the code from G also. I do not want to tell. Okay, that we discussed earlier, one of the lectures. So that is your goal. Okay, so at least certain things I need to leave it to you. Okay, okay. Now come to this. It is because linear independent dependent is now related to, see how G and H are related. H is actually the null space of G. G and H are like that. G is the null space of H. So dependent independent can be checked that way also. Right? Okay. Anyhow, that's why I want, do not, even you will confuse also if I tell both of them. Better concentrate one. Basically, H ka size is smaller in general. That's why it is better to look at H. Okay. So why two columns are different here? Any two columns are different here? If two columns are same, then they are linearly dependent. Then the distance of the code is less than or equal to 2. I'll repeat. If two columns are same here, then if two columns are same, then they are dependent. If they are dependent, then the distance of the code is less than or equal to 2. But already I know distance of the code is 3. That means no two are equal. That means any two columns are linearly independent. Do you remember that this code is related to something? Do you remember this code is something already known code? Yeah, any one of you know. Yeah, yes, please. This code is something you already know. This code has some name. Hello, are you there?
Hamming?
Hamming code. Okay, so you see, that's what you are not revising what happened in the previous class. Okay, so even I'm not uploaded the video or something, Hamming codes can be studied, right? So Hamming code pe all the non-zero rows will come, right? All the distinct rows will come here, right? That's why distance of the code is 3. That is Hamming code. Till now I am discussing last previous class ka Hamming code only. This very much clearly mentioned, but you will not refer, na? Yeah, so this is your duty. Okay, take one thing and computing everything is your duty. Okay. So you know that in the previous class it is checked, it is a perfect code, it is not MDS code. Is it a cyclic code? Can you check your code and see that, right? So I am not going now syndrome table and all. Okay, is any one of you computed the standard array? Can you say yes? Talk. Yeah, Pranita, are you computed a standard array for this code? Hello, Pranita. Aditi, are you computed?
No, sir.
Okay. So somebody can tell that coset leaders, first coset leader is what? One coset leader bata sakte hain?
0, 0.
0, 0, 0. Good. 7 vector, 7 length, 0. So can you give me one more coset leader? Easy now.
1 0.
1 0 0 0 0, because 1 0 0 0 is not a code word because the distance is 3, right? Good. Okay. So how many rows will be there in the standard array? At least that much you can say. See, total number of, how many total number of vectors here? Length 7. Hello.
Sir, 8 rows.
8 rows, okay. Total number of, what are the total number of words actually? Not code words, total number of words, how many are there?
2 raised to 7.
So
18.
total 2 power 7. Number of words, total number of words, right?
Yeah, I was.
Yeah, that's okay. Now I'm coming to you. 18 is not correct anyhow. Number of rows is 18. It cannot be. See how many, so that's what. So you are not actually checked what is standard array till now. Okay. Your goal is that somebody has to put a knife on your neck. Okay, then only you will do. Exam is there, then only you will do. वो तो समझ में आ गया मुझको. That's why I change it to Viva now. Okay. So anyhow. So how many vectors are there in the first row of the standard array? At least that much you can tell. Chetana? Hello, Chetana ma'am.
So
Yeah.
6.
Chetana, okay, go ahead. How many elements will be there in the first row? In the standard array पे first row क्या होता है? First row.
So the entire.
First row.
Sorry, Chetana, repeat one more time. Okay. So Pragati, what is the first row? Hello, Pragati, in the standard array, what is the first row? Pragati. Okay. Okay, Shruti ma'am, you can go ahead.
So it will be all the codes.
All the code words, right?
Yeah, code words.
All the code words will be there. There are total 16 will be there, right?
Yeah,
Now,
and then once you write the rows, cosets, you just keep adding and
16 only will go, right?
yes.
So
8 and 16.
So 2 power 4, 2
The
power
dimension.
4, 2 power 4, 2 power 4, like that I had to go. I had to get 2 power 7 finally, right? How many times I will do that? Is it okay, Aditi?
Yeah.
So how many rows I have to do to get 2 power 7? 2 power 4, 2 power 4, 2 power 4, 2 power 4. How many times I have to do? Each coset is distinct, right? First row contains 16 code words. Second row contains, see,
Again 16.
yeah. So see, please try to
8.
understand. I want to tell higher concepts, but delay हो रहे हैं. आपको समझ में आ रहे हैं, Aditi?
Yeah, sir.
Please do not take it. Otherwise, my point is that how can you read new things now? So that cooperation is required from you, right? So coset also contain the same cardinality as the code, right? So this also 16, this also 16. So how many 16s I had to add to get, what is 2 power 7? 64. So 16 plus how many 16s I had to do, right?
4 times.
4 times we need to do, right? If I do 4 times, I'll get that. That means there are 4 rows will be there in the standard array, right? So then there are coset labels. Right. Yeah. Please.
2 power 7 is
2 power 7 is what? That's what your question? Yeah. So actually, see.
no, sir. I understood.
Length of the code word is 7. So total there are 2 power 7 words are there overall. Out of them, 16 are code words. Remaining are not code words, right? If error happened, it can be any of these 2 power 7 pe hoga. If it is already code word, then syndrome is 0. If not, then it will be in one of the rows, right? So I remember that you yourself told that any two.
Sir, 2 power 7 is 128.
128. Okay, then there is a mistake. Okay,
and
sorry.
then there will be 8 rows.
8 rows. So that is what I think
because it's 2Q.
Okay, thanks. Okay, so sorry, thank you. So there are 128. Okay, so there are total how many rows will be there? Yeah, thanks.
Sir,
8 rows.
8 rows.
8 rows will be there. Yeah. So
It
mistakes
will
will be.
be 2 raised to n, and the each number of columns is 2 raised to k.
Right.
Then the number of rows is 2 raised to n minus k.
Right, exactly. So it is because 2 power n divided by 2 power k karta hu, right? Yeah, yeah. 2 power n minus k rows will be there. Number of rows also I can count. That is also going to be always a power of 2 only. That is another thing, right? Yeah. Okay, fine, good. So there are total 8 are there. 8 into 6, 8 into 16 is 128. We are done, right? So you need to figure out what are the coset leaders, right? And you need to find the syndromes. So that is what other question, syndrome table, right? Yeah. So I asked a syndrome table also. Syndrome table mein kya, what is that we put? Only coset, only 2 columns, coset leaders and syndromes, right? At least you people, very less number of students still left. I don't know how I bored maybe other people, they left, okay? So we should not tell fast, we should not tell too slow also. Yeah, okay, fine. So you understand that how to do all these things. Okay. So are you able to compute everything now? Pragati, are you clear?
Yes, sir.
Okay. See, I will add, as I promised earlier, I will not add this in the in our Google Classroom, but I will add in the website which I prepared. Okay, there I will add these problems, entire this part. So look at there. Okay. Yeah. So this problem completely solve yourself. Yeah. So how many of you can answer second question, question 2? So how G1 and G2 are related? Pragati, you told, can you repeat?
Sir, the last column is the uh, parity check of the row.
Row. Okay. So now how many, what is the weight of each word now? These 4 words at least here. First word, first
Sir,
row.
4,
Second row,
4,
third row,
4,
fourth row.
4.
Is it true that all the code words have 4? So now I have to add them, right? I know.
Yes,
Even
sir.
then, without actually doing, so is it possible for me to compute all weights, right? Okay, fine. So for example, I give some code word C1. Okay. So C1 into C1 is equal to 0 bataya. So means inner product. Okay, I'll write like this. What do you mean by that? When inner product of 2 code words is 0?
When they are orthogonal.
Orthogonal is very easy. But I am telling that binary code mein, binary pe, you need to tell
When they
me,
are distinct.
wait. So, okay, so let us see this. Is 100 and 100 both the same vectors? Are they orthogonal?
No, sir.
No. So now I am asking you,
No.
now Pragati. So I don't know, you are also not at all preparing. Okay. Means, so you are postponing things. Somebody will ask you questions, then only you will read. That is not going to work. No? Okay. So I am asking now a question. I told you that there is a code word. Inner product with itself is 0. So what we can say about C1? So
Sir, it is a 0 vector.
which one is 0 vector?
Sir, C1 and you have written C1 with inner product C1.
Right, yes, exactly. And it is 0, I told.
Yes, sir.
You are telling
So
that it
then
has to be
C1
zero
is it.
vector only. Yeah, zero vector will satisfy. You are telling that there is no other vector will satisfy, right? So that is what
No,
you
sir,
are.
there will be.
What about this first row? What is inner
Sir,
product
it
of?
is also there.
Why it is 0?
Sir, because we have added 1 4 times and we are in F2.
So now can you tell me that I have a binary code C comma C equal to 0? Then what you can say about C?
Sir, the parity of C is even. Oh,
Yeah.
1.
Parity of
0,
C.
0.
Parity of C is 0. That means what is
0.
the weight? What is the weight for which code words they are orthogonal to themselves? What about the weights? Can you tell me in terms of weights? A code word is orthogonal to itself. A code word orthogonal to itself. What we can say about the weight of that code word?
Sir, weight would be even.
Weight would be even, right? That is the simplest thing. So now all these are orthogonal to themselves.
Yes, sir.
Yeah. So that is helping that is it a self-orthogonal or not, right? Self-dual code is automatically self-orthogonal also, right?
Yes, sir.
Yeah. So everything is orthogonal to itself. So now how entire code is orthogonal, self-orthogonal first? How do you prove it? So how many vectors are there? First of all in the code? Hello?
2 raised to 4.
2 raised to
4.
4. Okay, because length is not changed still. Okay. What about C perp dimension?
It should be equal to C if they are self-dual.
No, but I do not, I have to check. Na?
16 minus dimension of
Dimension of CPUP should be 4.
Dimension is 4 because this dimension is
This
4, that dimension
dimension
is
is
also
also
4. So whose cardinality is also 2 power 4, right?
yes.
So now once these are equal, is it so to check that it is self-dual, is it sufficient to check it is self-orthogonal? I have two subspaces,
Yes, sir.
W1 and W2.
Their subspaces and the dimensions are same.
If one is contained in the other means that they have to be equal. Right? That is the idea, how to attack the problem. Right? Are you okay, Aditi? Why I'm asking these questions?
yes, sir.
Now we will prove that it is self-dual later. Hai na? Okay, good. So the dimension of this code is 2 power 4, dual code is 2 power 4. That much we can see from the matrix itself. Without looking the words, I just computed the dimensions and as well as the total number of vectors, sizes in the C and C complement. So first of all, that part is checked. They have to be equal for self-dual Kelly. So at least their numbers are, but equal does not imply they are self-dual. Okay. But is the code is orthogonal? If it is orthogonal, then I am done. Okay. Is it orthogonal to itself? First, the row vectors are orthogonal to itself. But now if I take any code word C, so why is it is orthogonal to itself? That I have to answer. Hai na?
Sir, it will be a linear combination of these vectors.
Okay, good.
So then if you take then you take the inner product, it ultimately becomes 0.
Very good. See, all of you understood that? Very simple. I'm just doing linear algebra only. Okay, so that means that the vectors which are orthogonal to G2, this matrix, are all of them, and there may be more, I don't know. There may be more vectors which are orthogonal to them, but at least, so that is the reason I put C perp. So C contained in C perp. All these vectors are already, so why C is contained in C perp? Every code word is orthogonal to every code word. So C is contained in C perp, I can say now, but the cardinality I can say all of them are equal. Is it okay? Good. So I'll ask one more question to you. Okay. So now I take two rows here. Okay, C1 and C2. So what is the weight of C1 plus C2? I am claiming that 4 divides the weight of this C1 plus C2 also. 4 divides. How can you prove that? Is the question clear, Shruti?
Yeah.
So C1, C2 are the rows. Okay. Now I am claiming that if I add them, still it is 4 divides them. Yeah. How to prove that?
Can I?
Yeah. Go ahead.
So, sir, the distance of the code is 4.
How do you know that? That for that purpose only I am doing all these things without actually computing. You done manually, right? Or you done some way? How you done? That how do you came to know that distance is 4? I am giving some more hints. Okay, that is the goal today. So okay, so go one by one. So do not use distance. So somehow you computed, your answer is correct, but not that approach. So I told you that 4 divides the weight of the C1. I told you that 4 divides weight of C2. So from that, can you say that 4 divides weight of C1 plus C2? Is the question clear, Pragati?
Yes, sir.
I am telling 4 divides weight of C1, 4 divides weight of C2, then 4 divides weight of C1 plus C2 also. How do you prove that? So somebody remember that in the previous problem session, I wrote that weight of C1 plus C2 in terms of weight of C1 and weight of C2. Or even now you can check what happening C1 plus C2 pay.
Sir, it's less than or equal to?
Less than or equal to is okay, but equal to karna hai. So I told you that at that moment A union B wala. Number of elements in A union B equal to number of elements in A plus number of elements in B, something like.
Component wise multiplication ka.
Very good, very good. You remember that. Wonderful. Yeah. So why component wise we need to multiply? Yeah. So I'll go. So already she answered. Okay, Aditi. It is weight of C1 plus weight of C2, right? Minus
Component wise multiplication.
But be little bit that I'm not completed. You why component wise come up, then you will tell the
Sir,
properly here. Yeah.
That's intersection, right?
So see, so I am adding these two, right? For
So
example,
we are
first,
repeating the common parts in weight of C1 and weight of C2.
Okay.
That's why we are subtracting it once.
Once only.
Yeah, because I
Okay,
have
let us go. Okay. What is the weight of the first code word here? This guy. Are you able to see? I am ticking here.
4.
4, right? This one 4. So now I add. So what is weight of C1? 4 plus 4. What is that I am doing now? So wherever common ones, how many times I have to subtract?
It's twice.
So I explained at that moment.
Yeah.
Yeah. So it is 2 times C1 star C2. Star means here I'll multiply component wise. 0 into 1, 0 into. So like dot product हम करते हैं ना, but I am now not adding them. Dot product हम कैसे करते हैं? ऐसे कर रहा हूँ. Component wise multiply कर रहा हूँ, but I am not adding them. Vector. So 0, 0, 0, 0, 0, 0, 1, 1. right? That one I added for C1 as well as for C2. So I had to do 2 times. But what you can say about weight of this guy?
It has to be 2.
No. In this problem, it is 2. In general, I am telling now general problem. मैंने बता रहा हूँ आपको. 4 divides weight of C1, 4 divides weight of C2, 4 divides weight of C1, 4 divides weight of C2. Then what you can say about weight of C1 star C2? Can it be 1? Is it possible that the weight of C1 and C2 can be 1? So, okay, let us assume that I am adding now extra thing to you. It is a self-dual code also. Suppose मैंने आपको वो भी दिया है, self-dual code. Then मान लो मैंने आपको self-dual code दिया है. Self-dual means what?
सर फिर तो होगा ना.
Self-dual means what? So each vector is here perpendicular to each vector in the code, है ना? Self-dual मतलब क्या है? First row is orthogonal to everyone. Second row is every vector is orthogonal to everybody, right? So C1 is orthogonal to C2, है ना? Hello, are you there?
Yes.
Yeah, C1 is orthogonal to C2. Then what is the head mod product? Component wise multiply करके तो weight. What about the weight of that one? What do you mean by weight of?
It will be 0.
It will be 0.
It will be 0 because when I are multiplying and adding, so these are orthogonal. So there should be so it this is 0, okay. But what about the weight? Now if I add, it is 0. So then what we can say about the weight? See, try to understand C1 slash C2 is not
It's even.
It is even.
Yeah.
Try to understand that it is even. So now it is also multiple of 4.
Yes, weight is the multiple.
So now
4.
C1 plus C2 also weight multiple of 4. Okay, think about, yeah. So I do not go further. So very beautiful actually, right? Yeah. This is the question I asked also in the previous also. I think 26 question is related to that, maybe 25 or 26. Okay, let it be. Okay. So now G3 is equal to, is it a self-dual, self-orthogonal? Self-dual. These are the questions, right? So any one of you?
It is not self-dual.
Why it is not self-dual?
So the dimension of this G3 is 1, and that of C is not equal to this.
C is how much? C power ka how much? That
2
also
to the power 4.
2 power
3.
3. Very good. 2 power 3, right? So
Yeah,
dimension
yeah.
of C is dimension of C is 1, then dimension of C power P is going to be 3, right? 1 plus 3 equal to 4 total code length of the code. Okay, so it is 2 power 3. So they are anyhow not equal. So they are not self-dual. But is it a self-orthogonal? That means is C contained in C per or not? So for that, what is sufficient to show? What is sufficient to show?
You take the
No, do not tell. No, you just tell me one simple answer. So to show that one, what is sufficient to show?
C is contained in C.
For that, to prove that one, what is that we need to show? One simple.
This basis is there in basis of G3.
Very good. Just rows are there in C per, right? But there is only one row. Shruti, you are telling, I know that. but I want to general, not for this particular problem. है ना? Okay, Shruti?
Understood.
Yeah.
So
So
this
in
is
general,
vectors.
all the rows are in C perp, we are done. So here also that is happening. All the rows are in C perp. Then C is contained in C perp. Okay. So that is the thing. So what is the diamond? What is the basis for C perp? So since it is perpendicular to itself, it is alpha orthogonal. So this vector is in C perp. So I am done actually. It is alpha orthogonal is clearly true. But even then, let us check. So can somebody tell me that dimension of C perp is 3, na? So somebody can give me the basis there. That means you have to find the vectors which are orthogonal to 1, 1, 1, 1, 1, right? Orthogonal to this. That is the C perp, right? Is it 1, 1, 0, 0 is in C perp? Pragati?
Yes.
Yes.
Yeah. What about 0, 1, 1, 0?
Yes, sir.
Yes. Are these two are linearly independent?
Yes, sir.
Yes. So they are linearly independent because
They are not equal.
they are not equal. Good. So 0, 0, 1, 1. So now any two are linearly independent. Okay. What about all the three of them? They are also linearly independent.
Yes, sir.
Yes, you can check that easily. That all the three are also linearly independent. Now, can it contain 1, 1, 1, 1?
Yes.
How do you know?
You just add first and third.
Yeah, add first and third. You will get 1, 1, 1. Right? Now it is there. So it is brute force completely checking. Okay. Yeah. So please do actually. You are able to do, right? You have that capacity. Yeah. So somebody can tell me now what is this number I have to put here? I'll repeat the question. So T is a T error correcting code of length n. Okay. And further, I am giving you that C is a dimension K binary perfect T error correcting linear code of length n. Right? Then what is this number? This number, yeah. So who will tell?
So can I?
Yeah, please go ahead.
So sir, it will be 1 here.
One only.
Yeah, because the cardinality of C is, I mean, the number of code words in C will be 2 to the power n, since the length is n.
Length is n, but I am not told it is a k dimensional.
1 plus n it will be.
1 plus n.
7.
Why 1 plus n? Because see, here equality means mod C is equal to 2 power n by. So dimension of C is k. So cardinality of C is 2 power k, right? So 2 power k equal to cardinality of C, which is equal to 2 power n by t equal to 1. So nc0 and nc1, right? So nc0 plus n choose 1. So that is 1 plus n, right? So finally, what is happening? So 1 plus n is equal to how much? Hmm?
2 raised to n minus k.
2 raised to n minus k. Very good. So what is n then? Yeah, 2 raised power n minus k plus 1, right? So if I take r is equal to n minus k.
-1, right?
Ah, okay. Thanks. -1. Thanks. -1. Okay. So when if I take r is equal to n minus k, then n is equal to how much? 2 power r minus 1, right? What is the k value? In terms of r?
N minus r. So 2 raised to r minus 1.
So do you think some code?
Hamming.
Hamming code again, right? This Hamming code, right? So this is easy actually. 1 plus n is equal to 2 power k. Can you give some numbers? Means 1 plus n become power of 2, right? Finally. ये वाला है ना? So are you able to find such numbers?
Yeah, 7.
7 is there.
3.
N is 7. Next n equal to
3.
now n equal to 3 also very good. N equal to 3, correct?
5. No, not 5. Sorry, 7. And
15, 31.
15.
Next to 31. Just 2 power k minus 1 कर लो, है ना? Right? Right. So they are exactly this, right? 1 plus 2 plus 2 square up to 2 power whatever, right? Yeah. Okay, fine. Good. Okay, see, these are the Hamming codes. Okay. So I have perfect codes for these numbers, binary perfect codes, but t equal to 1 case पे. Okay. So, but t equal to 2 case में क्या होगा, right? See, these are the questions you need to ask, right? I'll give the sphere packing bound. That is my duty done. I define what is a perfect code, my duty done. Okay. So you need to come up, you need to do solve problems. Okay, anyhow, come up now. T equal to 2. Yeah, Paranita.
So sir, it will be 1 plus n plus n choose 2.
Very good. N choose 2, right? 1 plus n choose 2 into mod c equal to 2 power n. Now you know mod c equal to how much, right?
Yeah, it's 2 power k.
Now can you tell me that 1 plus n choose 2 equal to how much?
2 power n minus k.
Very good. So now I want numbers, right? Such that 1 plus n choose 2 is equal to 2 power something. Hai na?
Yes.
Is okay. So I wrote here. So 2 power of 2. Can you find n such that 1 plus n choose 2 is a power of 2? Is n equal to 5 will work? Can we check? 1 plus 5 plus 5 choose 2. How much?
16.
16. So it is working. Okay. But so if this is the case, what is a t here? T equal to 2. So somebody can tell me what is k equal to here in this case? What is the distance of the code? So n equal to 5 now, right? N equal to 5 is
K is
working.
1.
K is 1. How do you know k is 1? Who is telling that?
So Shruti, sir, because it is 2 raised to n minus k, and n we took as 5. So 16 is 2 raised to 5 minus k. So it has to.
That way you told, but I want to tell in a different way. Let us see.
Okay.
So this is 2, right? That is good. This is just number theory, numbers and all. But t equal to 2, then what we can say about the distance of the code? It is a t error correcting. T error correcting.
Distance is 5 then.
So d equal to 2t plus 1, greater than or equal to, right? Greater than or equal to 2t plus 1. But n equal to 5, distance cannot be greater than 5. So it is exactly equal to distance equal to 5. Distance equal to 5 means which code words will have, which code has distance 5?
Repetition.
Repetition code. Then what is the dimension of the repetition code?
1.
1. That way I want to find it. Is it okay, Shruti?
Yes, sir. Understood.
Beautiful. Yeah. So but it is natural that we'll try this way, n minus k. But so this is not much useful. This is a repetition code. I need a non-trivial codes, right? So, but interestingly, they are nothing. Non-trivial codes are not there. Okay. T equal to 3, then people try t equal to 3. This is interesting. Okay. So then one person called Gole, Okay, so his name is Gole. So he tried actually. So when n is equal to 23, it is working. So can somebody first tell me that equation? You know that it is equal to 2 power n minus k, right? T equal to 3 case. Here, what is that? 1 plus, sorry, 1 plus n choose 2 plus n choose 3. यहाँ तक जाना पड़ेगा, right? Okay. So you check that n is equal to 23, it will work. Okay. So then what is k value? Yeah, so try to find out. This is interesting. So one day I will try to prepare my video and share with you. It is one of the beautiful code actually. So many ways it can be constructed. So much mathematics is involved. Okay, very, very beautiful code. So at least one of you will read at least by end of this course, Gole codes. Okay, that is my sincere advice, and I will be happy. Okay. Now somebody can give me the answer here. I already told before once, but what are NKD values?
322.
322. Good. So n equal to 3. So that is length of the code, and 2 dimension. Distance is also 2. How do you know distance is 2?
So linear code. So you can just find the weight.
Yeah, it is a linear code. So because of that, very good. That's why we check the weights only. So no need to look at the distances. Weight is 2, weight is 2, weight is 2. Non-zero code words ka weight dekhna hai bas. Very good. Yeah. So linear code, that is advantage. Okay. Why it is a linear code? You know that. Sum of these two is this. So done. So it is a cyclic code. So what is the polynomial corresponding to this?
One plus x.
Very good. Thanks. It is 1 plus x. So what is the polynomial corresponding to this?
1 plus x square.
1 plus x square. Very good. So this one, x plus x square. Yeah. So is it coming by multiplying by x? So let us see. This comes by multiplying by 1 plus x. So how much? X, right?
Yes, x plus x square.
Yes, plus x square, right? So
Then
x
if
plus
you
x square
multiply
is this.
x,
It will multiply by x cube. I will get. No, sorry.
x square.
X square, x square. Yeah, x square. If I multiply, then I will get
x square plus x raised to 4, which is
X.
Yes.
So I'm getting the same. What is the problem? What is happening? So 1 minute.
But we'll multiply the first 110. 1 plus x will multiply by x and x square.
Yeah, okay. Okay, this one we need to multiply one. Yeah, sorry. This you multiply by x, I'll get x plus x square. If I multiply this by x square, yeah, you are correct. I'll get 1 plus x square. So what is the generator polynomial then for this code?
1 plus x.
1 plus x. So you know that the generator polynomial is degree is 1, then code dimension is 2, right? Generator polynomial is n minus k. Please remember that. It is much better actually, right? Is it a self-dual code? So in one my question I asked these, okay, in the cyclic code notes पे आप देख सकते हैं. So actually 1 plus x divides the generator polynomial, or it is itself a generator polynomial, then automatically it is self-dual, self-orthogonal, self-orthogonal. Why? That you can check. But I want to tell you one thing here. What is the parity check polynomial for this?
X cube plus 1.
No.
X cube minus 1.
See, that is entire. X cube minus 1 is the entire. This is equal to the divisors of x cube minus 1 are the generator polynomials, right? X cube plus 1 or x plus 1 both are same. X minus 1 are the same, right? So g of x into h of x, that is the parity check polynomial. What is that? You are not at all studied. Okay, this is
1 plus x
plus
plus
x square. Now, what is the if this is the generator matrix, but you know that what is the reciprocal of this? Reciprocal means I interchange the things, right? It is self-reciprocal. You can easily check. It is again, if you do 1 by x karke, in the place of x, if I substitute 1 by x and multiply by x square, I'll get the same polynomial. It is self-reciprocal. So now I will write a matrix like this, right? So once it is there, this 1, 1, 1 is there, then you can easily check that my original code is self-orthogonal, right? Everything is perpendicular to this. Yeah, so with that you can understand that self-orthogonal part. Okay, anyhow, I'll not go into this now. Okay. So somebody can tell me that for C2, what are the for C2, what are the NKD? First, what is NKD here?
414.
414. Good. That is done. Is it a cyclic code?
Yeah.
Yes, it is.
Yeah, it is cyclic code. So if you wait for some more time, give me some 5 more minutes. So I try to explain a few more things. Okay. Yeah. Yeah. So it is cyclic code. What is generator polynomial? So his dimension is 1. That means the generator polynomial degree is how much?
3.
3. Very good.
So it's 1 plus x square plus x cube.
Very good. 1 plus x square plus x cube. Generator polynomial is that. Okay, good. So this is the generator polynomial. Okay. If I multiply by x, this one what happens?
We get the same thing.
We get the same thing. Very good. We get the same thing. Beauty. Right? Good. Okay. Nice. These are done. What about is it a linear code? How C3 is formed? Just adding, right? Yeah, so please check these things. So, but I already gave the answers. Okay, now time is running up. So this is actually C3 direct sum. This code is called direct sum. And here N1 and N2 are different maybe. But generator matrix is like this, G1, G2. Okay, so try it. It will be very simple and easy. Okay, so this I told you earlier. So here the generator matrix is like this, G1, G1, 0, G2, right? So just I want to just tell you a few things about read Muller code. Okay, that is the need. 5 minutes. But okay. So R11 is already this. R11 is this, right? So R12 is, so I told you that you will add this earlier one, right? Shruti told here how we computed last 2 columns, you may remember. She told last 2 here, right? So just to recall this, okay? Na? I hope you recall that. What is that we are doing in this code? So u comma u plus v. So u comma u plus v. U is this and v are these two, right? U plus v में क्या होगा? So u plus v पे so we are putting this as it is and we are adding v to everyone, right? So second part. So 0 0 0 0 0 0 plus 0 0 0 like that. Okay, 1 1 0 1 1 0 plus 1 0 0 0 this. So it is repeated here. 1 0 1. So 1 0 1 again. I'll 1 0 1 ko I'll add 1 1 1. So next row, right? So I'll get 0 1 0. So we remember that. Okay, so that way we'll get. And what are the what are the parameters also you can check, right? So it is exactly, now it become 2n k1 plus k2 and minimum of dt1 d2. Okay, yeah, okay, fine. So as a special case, now I'm fixing C2 is this repetition code. Okay, then you'll get to 2n comma k plus 1 comma minimum of 2d comma n linear code you'll get. Okay, so then Reed Muller code. So okay, so actually Reed Muller codes are among the oldest known codes, have found widespread applications. For each positive integer m and for each real integer r, satisfying this 0 less than or equal to r is less than or equal to m, there is an rth order Reed Muller code. Okay, so it is a binary linear code. So n value is 2 power m and k is mc0, mc1 up to m choose r. You can check that it is actually, from this can you conclude it is a perfect code? Okay, so it is a perfect code. Okay, right, and distance is 2 power m minus r. Beautiful, distance is very big, right? So in fact this r1 comma 5 is used for the Mariner robot. Okay, so that spacecraft, so transmit black and white pictures of Mars back to Earth in 1972. Okay, okay, so first I'll define R1m, then we'll go to Rm later. So when my R value equal to 1, that is called first order Reed Muller code. So here it is defined recursively like this. First R11 is this code, R11 is given, Rm plus 1 is UU when U belongs to R1 comma M, and U union U plus 1 U belongs to R1 comma M. Okay, I'll explain you R1 comma 2. Okay, so R1 comma 2 kaise karenge? So 0 0, so U first, right? U added to U, so that is actually you are adding the 0 0 vector, right? 0 vector to U, right? So when C1 plus C2 is repetition code, right? 0 0 to 1 1. So I hope this you understood. Now in this code there are three linear independent columns are there. So but better way you write generator matrix like this. So 1 1 1 I put here, 0 1 0 1 and 0 0 1 1. So all of them are here, you can check. So this is the generator matrix. So it is for some reason we are doing like that. So you look at for G1 also I took 1 1 and 0 1, right? So in general you can extend it. It is like GM here, all 0 rows and 1 1 1. For example, G3 code, G3 matrix is like this. You see G2 here, right? G2. So check once, 1 1 all ones, 0 1 like that. Then G2, these 4 zeros and 1 1 1 I put here. Okay, that is like that. So what is happening is that, so R1m becomes 2 power m plus 1, 2 power m minus 1 code. So it is similar to here. So you checked it earlier, right? So this somewhere I put k1, k plus 1, yeah, here, right? M plus 1. So minimum of 2d comma n. So that 2 into 2, that multiplication 2 power m and 2 into 2 power, so that minimum also 2 power m minus 1 will come that. Okay, from that. Easy to check. Yeah. So one more interesting thing is that for every code except 0 0 1 1 1, every code word has weight 2 power m minus 1. That is a beauty. That also can be proved very nicely. Okay, that means weight distribution is like this. There is one word of weight 1, one word of weight 2 power m, only one word, that is all ones, but remaining all are weights are 2 power m minus 1. Why this is equal to 2 power m plus 1 minus 2? N is equal to 2 power m. Okay, anyhow, so dimension is k. Dimension is k. With that you can understand this. Okay, yeah. So later people developed for general R also. So recursively they defined. With that I will stop. Okay. Yeah. So this is also, just let me just define and I will close it. So 0th order read Muller code is 0, m, that is a repetition code. First order we defined above. Rth order read Muller codes again defined recursively. So when m equal to r minus 1, it is m2 power 2 power r, f2 power 2 power r. If it is m is greater than r minus 1, then it is again defined recursively like this, u comma u plus v. So yeah, so you can check later, watch video, and these slides I will upload in the Google site. There also you can check. And these are, I taken this content from the Ling, Zing and Ling book. Okay, there also you can check. Yeah, with that I'll stop. So any questions?
No, sir.
Okay. Okay, then best of luck. So we'll not meet in the next week, right? Am I correct, Pranita?
Yes, sir.
We'll meet
We
only
have
for the exam, of course. Wednesday we have exam, 3 to 5. At that moment we'll meet, right? Yeah. Okay. Best of luck for your exams and work hard.
Thank
So
you, sir.
I motivated as much as possible to do things. Aditi, is it everything fine?
Yeah, yeah, sir.
Okay, fine, good, thanks. So you can leave now.
Sir, I just
Mm-hmm.
you will be uploading the question paper on Google Classroom itself on Wednesday.
We will do that. Yeah, I will check it, how to do that part. Yeah, maybe most probably it is like that only.
Okay.
Mm-hmm. And you will write down and then submit, right? Generally, how, that way also you do, right? That approach also you will follow, right?
Yeah. We write down, then make a PDF and upload Google file.
Okay.
Or email or Google
In the
anywhere.
classroom, or you can send it a mail anyway, right?
Yes, yes.
Yeah. Okay. Okay.
Sir, theory and examples, everything will be there.
Right. Yes. So see, that's what. So try to solve as many as exercise problems which I already gave. I think in the 4th, 5th or something, I given some questions. You remember? At that moment, I asked that maximum likelihood method, probability wala questions diya hai.
Yes.
Aapko some, few of you can remember that.
Yeah.
Yeah. So